Hello, my fellow mathematicians. Welcome to the little corner of the internet called Marshable Math. Today's lesson is going to be completing the square in order to solve quadratic equations. So get yourself a piece of paper and a pencil handy, and let's get started. All right, so consider the quadratic equation x squared plus 6x is equal to 7. Now, at first you may be thinking, well, there are several different ways I can factor this to solve it, or I might use the quadratic formula or something along those lines. But let's use this method here that's called completing the square. Now, if you remember when you factored things, if you had something that was in the form of a squared plus 2ab plus b squared, you know that that factored down into a perfect square trinomial, a plus b. When we have something in this form, we can then easily take the square root, and that allows us to solve the equation. So how do I take this and get it into the form which makes it a perfect square trinomial? Here's a little checklist I'd like you to write down. Okay? The first thing we're going to do is we're going to write it in standard form, where I've got ax squared plus bx plus c, which, as you remember, a, b, and c are the coefficients on the x terms, and it's in descending degree. So let me do that first. Let me first subtract 7 from both sides. Let me get x squared plus 6x minus 7 is equal to 0. And now I'm going to go through this checklist here, okay? So number 2 says separate the c term. By separate, it just means I'm going to pull it apart from the other group. So I'm going to write x squared plus 6x, leave some space, put Mr. C way over there by himself. Don't mind, he kind of likes it, okay? So don't be offended if Mr. number 7's way over there by his lonesome. Now, what I'm going to do then is I'm going to focus on this group, and oftentimes it may be helpful for you to put parentheses around that group with a little space here, because we're going to put it into this form right there. Now, number 3, factor a from the remaining x squared and x terms. A is the coefficient on our x squared term. In this case, it's just 1. So I don't really need to factor anything out of there, because factoring 1 out doesn't really do anything for me. So I want to proceed now to step number 4. Step number 4 is where the big ticket item is. We're going to take half of the remaining b term, in this case it's 6. We're going to take half of that, square it, and add it into the x squared quantity, into this group right here. So what's half of 6? That's 3. What is 3 squared? That's 9. So let me add 9 into this group. But now I've just changed the equation, right? You know that whatever you do to one side of the equation, you have to do to the entire other side. But in this case, I want to keep everything that I do on the left. I'm going to leave that as equal to 0 over there. So if I add in 9 to the left side of the equation, how do I undo that also on the left side of the equation? Well, what's the opposite of add 9? Subtract 9. So let me just subtract 9 here. And as you can see, plus 9 minus 9, I've really added in 0. I haven't really changed it. I've changed the form, but I haven't changed the value. So now, maybe you'll recognize this as a perfect square trinomial. Yes, so it factors down into x plus 3. This number here is always going to be either half of your b term or the square root of whatever you have to add in there. That's the relationship. Now, let me combine the like terms here. That's what? Negative 16 is equal to 0. Now I've got it set up in the form that I want it to be in. I've completed the square. See, now it's a perfect square trinomial. Okay, so how do we solve this here? Quite simple. We just use reverse order of operations. So let's see here. We got please, my dear Aunt Sally, or Pale Elvis meets Dracula after school, or something like that, right? I'm just going to go backwards now in order to solve this equation. Is there something subtracted from the x term? Yeah, it's 16. So I'm going to add 16 to both sides, plus 16, plus 16. I'm going to get x plus 3, quantity squared, is equal to 16. Okay. Now, nothing added, nothing divided, nothing multiplied here. Finally, I'm at the exponent. How do I undo the square? Square root. So let me square root the left side, square root the right side. It undoes the grouping here, so I get x plus 3. That's equal to square root of 16? It's 4. But did you remember the plus and minus? Yeah, it's plus and minus 4. Because this question asks what when I square it gives me 16. Well, both the positive 4 and the negative 4 also do that. Don't ever forget that. All right, now I solved it by really doing two separate little problems here. This is going to be x plus 3 is equal to positive 4, and x plus 3 is equal to negative 4. And if I subtract 3, I get x is equal to 1. And if I subtract 3 here, I get x is equal to negative 7. Okay, so here's my answers. I've solved it by completing the square and then extracting the root. That's what this process is called from here on down. Okay, some of you, if you get really good at this, you'll make a pretty good dentist, right? Because dentists are interested in extracting the roots. Yeah. So you may be thinking, man, couldn't I have just factored at this point and gotten something like, you know, what? Factors of 7 that when I subtract them give me 6. X plus 7, x minus 1 is equal to 0, and then solved it using the zero product theorem? Yes! But what if it doesn't factor? Let's try one of those. If it doesn't factor, you can still use the completing the square method. So, try this one. X squared minus 4x minus 1 is equal to 0. Write these down if you haven't already, and press pause on the video and try to solve that using these steps here. Okay, number 1, standard form, already there, so good to go. Number 2, separate the c term. All right, so x squared minus 4x, leave a space, minus 1 is equal to 0. In fact, I probably ought to have a little group here going on. Now, factor out the a. Well, it's already 1, so no need to do that at this point. I'll give you one in a minute that you'll need to do that with. All right, so take half of your b term. Half of 4 is 2. Square that, also 4. So add 4 in here, and it's always plus. Plus 4. How do I undo plus 4? Subtract 4. Now, this is a perfect squared trinomial. Something squared. X. There's the minus sign, drop that in. What's half of 4 and also the square root of 4? Same thing, 2, right? So minus 5 now is equal to 0. This one didn't factor. I don't have any factors of 1 that when I subtract them give me 4. But I can solve it now using the completing the square method. Okay? So now I'm going to switch to blue. Let's extract the root. Add 5 to both sides. X minus 2 squared is equal to 5. Take the square root of the left and the square root of the right. X minus 2 is equal to plus minus root 5. And then if I add 2 to both sides, I would get x is equal to 2 plus and minus root 5. And if it doesn't simplify down into just like a regular integer or fraction or something like that, just go ahead and leave it in this form. The non-irrational number plus and minus, and then the square root that doesn't simplify. Okay? Now, here's one where you've actually got an a involved. Try your hand at 2x squared minus 8x minus 3 is equal to 0. Give it a shot. Go. Okay, standard form. Here we go. Separate the c term. 2x squared minus 8x space minus 3 equals 0. I want that group now, but I've got an a here. Factor that out of both the x squared and the x terms. You're going to factor that out. 2 factored out leaves me an x squared minus 4x, leave space, minus 3 is equal to 0. Okay, this is going to run through the problem now. Now, inside here, half of the remaining b term, half of 4, square it. It's plus 4. But I can't just say minus 4 here. Can you tell why not? Because I actually didn't add in 4. I added in 2 times 4. When I distribute this 2 in there, if I were to do that, wouldn't this be actually 8? So I didn't really add in 4. I added in 8. So to compensate, that kind of rhyme, I'm going to subtract off 8. Now this reduces down. 2x minus 2 squared minus 11 is equal to 0. Now you can solve it using the